vapor pressure of the binary solution, which is made up of non-volatile solid solute plus volatile liquid solvent. So last session we dealt with both the liquids, both the solution made of liquid which are volatile in nature. So their partial pressure of the total pressure of the solution depended on both the partial pressure of the solute and the solvents at their pure state, right? Now like independently when you apply the Raoult's law, so the partial pressure of the solvent directly proportional to the mole fraction of the solvent, and when you put the proportionality constant as the partial pressure at the pure state, similarly for the solute, partial pressure of the solute directly proportional to mole fraction of the solute and the proportionality constant as a P naught B. When the solution is made up of non-volatile solute, for example, when you have volatile liquid solvent, so you can see a lot of vaporization happens. So the moment when you add a non-volatile liquid, the rate of vaporization decreases. For example, when you just keep the water as such without any solute, the rate of vaporization increases. The moment you add any salt like sodium chloride or potassium chloride, what happens? The vaporization of the water decreases. So that's the effect of non-volatile solute. So that time when you are going to measure the partial pressure of the solution. So now we are measuring the overall solution. So the partial pressure of the overall solution, it only depends upon the mole fraction of the solvent, because that only able to form the gaseous state, right? And so solute, it will not form the vapor state. So hence it will not depend upon the mole fraction of the solute, it only depends upon the mole fraction of the solvent. So when you put the proportionality constant, which is the P naught solvent and the X solvent, okay, and I am just bringing this multiplication as the division X solvent. In this equation I am just both the sides I am just subtracting this equation from 1 minus this and 1 minus this, and we know that X solute plus X solvent is equal to 1, right? So X solute is equal to 1 minus X solvent, okay? So 1 minus X solvent, I can write it as a X solute or XB, okay? X solute are equal to XB, and this becomes P naught solvent minus P solution divided by P naught solvent. This whole term is known as the relative lowering of vapor pressure, okay? It's a relative grading, like you have what is the average, and average by your original value divided by the average, right? Similarly, so this is known as the relative lowering of vapor pressure. So you can say Raoult's law in other words as well. So it is one of the qualitative property. The relative lowering of vapor pressure is known as the one of the qualitative property. So the relative lowering of vapor pressure of a non-volatile solute in the liquid solvent, which is equal to the mole fraction of the solute, okay? So this is the statement for the Raoult's law. So whatever the solutions which are following the Raoult's law are known as the ideal solutions, and this equation is valid at a given temperature. When the equation is followed by the solution, they are known as the ideal solution. If the solutions are not following the equation, they are known as the non-ideal solutions. That anyway we discuss in the next session. Hope you understood this one, okay? If there are any doubts, you can put it in the comments. Thank you.